Okay, so many things that I have to explain about this one. Okay, first, this is a function, and that function is a product of two functions. Okay, the first function is 2x, and the second function is sine squared of x. Okay, but before I write that down, it's important we understand what sine squared of x is. It's actually this. Okay, and it's important. And if you want to know why they write it like that, it's because it saves them the need to having to write those parentheses. Even though you see that they wrote them there, that's the only reason I can tell you that they do that. But it confuses people to no end. Another thing I want you to know is that sine squared of x is not the same thing as sine of x squared. See, when you look at this, it makes me think, like, what the heck does that mean? Well, it means this. Okay? So you got that?
Yeah.
Now, since it's a product of two functions, we're going to have to use the product rule, which is first times derivative of the second plus second times derivative of the first. Do you remember that? So let's find the derivative of the first. What's the derivative of 2x, Adrian?
That's
Okay, there's a 1 up here. So you just do 1 times 2,
2.
and then times x to the 0 power, which is 1, it's gone. So the derivative of 2x is just 2. Okay?
Okay.
What that means is that if you think about what the line y equals 2x means, isn't that what it looks like? Y equals 2x. You see this line right here?
Mm-hmm.
What's the slope of that line?
2.
That's right. That's why the derivative is 2. Because the derivative gives you the slope of the tangent at all points. And the slope of this never changes. It's always 2. Okay? All right, now here's where it gets complicated. To find the derivative of the second, you're going to do 2, the power rule here, times the sine of x to the first power. But then you got to multiply by the derivative of what's inside. So you'd have to grab your equation sheet. What's the derivative of sine?
Cosine.
Yeah. Very good. Okay.
That would help the sheet too.
That's right. That's right. Good job, Adrian. So now, to find the derivative of the function, we got to do the second derivative of this thing? Holy cow. So the derivative of this will be first, 2x, times the derivative of the second, 2 sine of x, cosine of x. First times derivative of the second, plus second sine squared of x, times the derivative of the first, times 2, okay? Well, now we got to take the derivative of that again. So here, look, we got another chain rule. Here's the first, and here's the second. So we're running out of room, so I'm just going to go straight to it. Okay, first, 2x times the derivative of the second. Okay, I'm going to have to take a little aside here. 2 sine x cosine x. All right, now I got to take the derivative of this thing, Adrian. So for that particular thing, I have to do the product rule. First, 2 sine of x times the derivative of the second. Derivative of cosine is sine. No, negative sine. So I'll put it over there, okay? First times derivative of the second plus second times the derivative of 2 sine of x. So that's 2 cosine of x. Oh, look at that. Gonna have to tap into some trig. Oh no, we're not. That's positive. So you get negative 2 sine squared x plus 2 cosine squared of x. All right, so that's the derivative of the second. First times the derivative of the second. okay, plus second 2 sine of x cosine of x times the derivative of the first 2. This is crazy. I got to erase this to just buy some room. Okay. First times the root of the second plus second times the root of the first plus. Now I have to take the derivative of this, which is 2 times 2 sine of x to the first times the derivative of the sine, which you told me was cosine. So I wish I could scroll down on this. So what are we going to have? Morning, Mr. Ray.
Good morning. Some of you guys haven't signed in. Like all of you guys.
Come on.
I'm sorry about that.
That's all good. You're in here grinding.
The sign-in sheet's right behind us, guys.
Rushi. Liam. You got Stapleton there? Yeah.
Yep, he's in here.
Tobina.
She's in here.
Thank you.
Thank you, Mr. Ray. All right, we're almost there, Adrian. Look, these two combine to give you this. And then all they did here was they factored out a 4x and then left it like that. And that's a tough problem. I don't think there's anything that hard on your test. Boom.